So the reason for the voter to exist, it's it basically replaces all found hashes that miners find. So with Bitcoin, when you discover a block, you discover a cryptographic solution. You then add it to your own ledger on Bitcoin, which is then broadcast over peer to peer to the rest of the nodes. The rest of the nodes on the Bitcoin network replay your solution or the discovery of the block. If it matches the difficulty plus the target nonce, which is just a number, then every node on the network agrees that your block is the legit block. If you fake it and actually submit a solution that is incorrect, so you haven't done the proof of work, then the rest of the nodes will simply reject you. And so that is the how Bitcoin blockchain does verification. So miners discover the blocks. It takes them days, hours, whatever, based on the hash rate that they have. Then those hashes must be verified, and then the chain is built. In our case, we're mining Xenium, and Xenium must be issued as a token for a discovered hash. Now, how do we know that the hash is accurate? All we know is that the hash comes in and it has a counterpart, which we call a key. A key is hashed into a proper result, and the proper result is basically Zen11, which is XEN and two digits 1 and 1. If it translates into that target, then the key that the miners have submitted is obviously accurate. But we need to have a consensus among within the network that this solution is actually resolves to the proper solution. So that's where the voters come in. Voters run a stripped down version of the Argon 2 hashing protocol. They receive the keys from the miners, and then they replay the hashing part from the key that's been discovered. Therefore, the result of verification is nearly instant because you actually do not need to search for, through the million of keys to find the proper hash. You already given the solution, and you just need to run it once to verify to see if it's really indeed the right solution. Now, if a single voter verifies it, that's one vote. Now, let's assume we have 1,000 voters. What we need to have is we need to have a supermajority consensus that the voters somehow agree among themselves that the hash is accurate. And once we hit 667 nodes out of 1,000, agreeing that basically everything looks accurate and the same, they all submit the same hashes, then the smart contract or a program on X1 will receive all those attestations and issue Xenium to the miner that actually produced that hash. So it seems like a complicated process, a consensus on top of consensus with verification of a hash. But this is the only way to actually run decentralized verification is when you have a quorum of basically verifiers that agree on a solution altogether, and there's a supermajority of those voters to verify. So when you run a voter on a web page, you're basically running Argon 2 verifier, and you're given all of the hashes, basically the workload to verify and attest that the miners have done the proper work. And generally, a single block in my design and design of Xenblocks contains 100 hashes. So you fetch this block of a set of 100 hashes from the blockchain that hasn't yet been verified. Then you very, very quickly, under 2 seconds, verify this 100 hashes and basically submit a fingerprint, which is the hash of all of the work you have done. And if this hash matches everybody else's hash, we achieve supermajority consensus, and Xenium then is issued to the 100 miners that exist in the block. So that's pretty much how it works.
Okay. Appreciate that.